This video will be covering section 6.2, graphs of exponential functions. In this video, we will learn how to graph exponential functions, and we're also going to talk about writing equations of exponential functions. So, here are some characteristics of exponential functions. We start with a parent function, which is b to the x. An exponential function with the form f of x equals b to the x, where b is greater than 0 and b doesn't equal 1, has these characteristics. It is a one-to-one function. It has a horizontal asymptote at y equals 0, so it's not going to cross y equals 0 right there. The domain is from negative infinity to positive infinity. The range goes from 0 to infinity. The y-intercept is at 0, 1. And then if your b is greater than 1, then it's increasing. A lot of times we call this growth, exponential growth. And then if b is less than 1, we consider it decay. It's decreasing. So those are the characteristics. So to graph a function, basically, all you need to do is create a table of points, plot at least 3 points from the table, including the y-intercept. So make sure you have the y-intercept included. Then you just draw a smooth curve. They may ask for the domain, which is negative infinity to infinity, and the range is 0 to infinity. And the horizontal asymptote is y equals 0. So let's sketch the graph of f of x equals 4 to the x. So we're just going to make a table of values, and it said we need 3 points, so one of them needs to be the y-intercept, so that's where the x is 0. So I'm going to put in those points, and I'm going to use Desmos to help me out. So I'm going to type in 4 carried to the x power. Then I'm going to hit this little wheel at the top, and I'm going to hit table of values. And I can see that my negative 1 is at 0.25, 0 is at 1, and 1 is at 4. So here we go. Negative 1 is 0.25, 0, 1, and 1 is at 1, 2, 3, 4. Okay, and then we know that there's a horizontal asymptote here at y equals 0, so it's never going to cross that point there, or that line. So there we go. There is the function. Alright, and that's all you have to do to graph it. Desmos is our friend. So the OpenStax really likes to go into using transformations. Now, I'm not going to make you use that method. Obviously, you can use Desmos to help you find your points. This does kind of help you to see how things shift, though, and how it changes the domain and the range based off of the transformations being made. So if we have the function b to the x plus c plus d, so notice what happened. Before we had just b to the x, now we're adding c to the x and we're adding d to the entire function. So as you may recall, the plus c added to the x, that's going to be a horizontal shift. Okay, it's going to go the opposite direction of c. The d is a vertical shift. So what happens? What does that change? Well, that's going to change the range, which was from 0 to infinity. Now it will be from d to infinity. Domain is still negative infinity to positive infinity. It's also going to change the y-intercept. The y-intercept is going to shift up this many spaces. Okay, so let's look at an example. So we have f of x equals 2 to the x minus 1 plus 3. State the domain, the range, and the asymptote. Domain is still negative infinity to positive infinity. Range was from 0 to infinity, but now it's going to go from D, which is 3, to infinity. And then the horizontal asymptote is at y equals 3. So I'm going to draw, oops, that's not 3, a horizontal asymptote at y equals 3. All right, now let me show you where the y-intercept was. The y-intercept was here at 0, 1. Now we're going to shift it. We're going to go right 1 and then up 3. So if I go right 1 and up 1, 2, 3, there's my new point, which was the y-intercept, but now it is no longer the y-intercept because it has shifted. Now I can go to Desmos, and I can type in 2 carried to the x minus, actually when you do this, you need, if you have more than just one number as an exponent, you need to put it in parentheses. So what did we say it was? X minus 1 plus 3. Okay, so notice there's this point here. Actually, we can just do a table. And so 1 is now 4. So check out this point that we have. I have this point here, 1, 4, because I shifted. And let's see if there's any other nice points. 0 is 3.5. 2 is up 5. So I can plot that point. 2 is up 5. And then I can just draw the graph from here. There you go. So do you have to be able to shift it to be able to graph it? You shouldn't have to. You could actually just put the equation into Desmos. But it does help to identify the asymptote / range so that you know where it doesn't need to go lower than. So this graph shouldn't go lower than than y equals 3. Okay, so let's look at this one. Let's state the domain and the range and the asymptote. Okay, so the domain is still negative infinity to infinity. The range, since we're not adding anything here, the range is from 0 to infinity. And the asymptote is at y equals 0. But one thing on here that is actually nice to know, and let me see if it tells us in the slide before. This is what you need to know from this slide, and I kind of skipped over it. The y-intercept is 0a. So if there's a number in front of b, that number is the y-intercept. That's the initial value. So the initial value, the y-intercept, in this case, is 1/2. 0 to 1/2. So I can see if I were to graph this that it's going to cross right here at 1/2. But then I can use my Desmos to help me find a couple other points. So I have 1/2 times 4 carried to the x. So here's that point 0 and 0.5. And you can look on Desmos and try to find some other points. Or you can make a table, and it looks like 1 will go up to 2, and 2 will go up to 8. So 1 goes up to 2, 2, 8's up here. So it looks like something like that. Okay? Okay, so I'm going to skip the final slides because it focuses more on transformations. And I think as long as you know whether it's growth or decay, and you can identify the y-intercepts, domain and range, you're okay because you can use Desmos. But what I do want to talk about real quick is let you know that they are going to give you some graphs on Newton where they will ask you to write the equation of the graph, and this is just like we did in section 6.1. So start with the y-intercept, and that would be your A, and then pick another point to go in for x, and then your function, your y, and use that to solve for b, and then you can write your equation. Okay, so yeah, so that's all for this section, and if you have questions, let me know.